Hello everyone. So this is the experiment number 7 which I am going to discuss today. Um, Let me first read its object. So in this particular experiment we need to plot. So this is the LCR circuit in fact, and the object for this particular experiment is to plot the resonance curve, that is the current versus frequency, for a series LCR circuit for the different values of resistance. Okay, and once you had plotted that, then the second part of this experiment is to determine the bandwidth and quality factor of this circuit using this resonance curve. Okay, so let me just show you what to do. So as you could see, actually in this manual you could see actually we have got the series LCR circuit. What we did, we have a resistance R and inductor L and capacitor C. These are all connected into the series, and one end of the capacitor goes into the frequency oscillator, and another end of on the other end of R goes to another end of the AF oscillator through an ammeter. Okay, so let me just show you the connection, how it visualizes actually. Okay, so let me just show it to you. Here is your AF oscillator. Okay, and what we did, you have this wire, one of its end goes to a resistance R. Okay, and another end starts via the ammeter, goes to the L. Another end of L is connected to this is I'm sorry, yeah, that's L, inductor, and inductor's one end is connected with the capacitor of 1 microfarad, as it says over here. Another end of the capacitor is connected to the second end of the capacitor. So this is how the whole connection looks like. Okay, now what we need to do is the following. So let's first check the table that will itself speak how to perform this particular experiment. This is the observation table we need to fill by. So what it says, that we need to find out the values of current in milliampere for different values of frequency for a given value of R, and of course L and C, they are also fixed. Here you have L is equal to 100 mH and C is 1 microfarad. So R, we will do this experiment for 3 different values of R, the resistance 50 ohm, 100 ohm and 200 ohm, and we will record the values of current into the ammeter for different frequencies, which we will dial through these knobs into the frequency oscillator. So let me show you. This is the variable as it reads over here, frequency variable. So I could just change and the reading over here would change. See, I'm just moving down in frequency. Right now it says 66 kilohertz, but I am supposed to take the readings in multiples of hundreds of frequency and go up to 1000. So let me first try to move to 100 hertz. So this is 98, 76, 149, 42, 23, 36, 1, 1, 2, 3, 4, 17. This is very sensitive, so we need to be very careful in moving. Okay, so suppose you have dialed this frequency, this is about 100, and then what you need to do, you need to record the reading over here. For example, right now it says 10, so 5 units are divided into intervals of 2, so the sensitivity is 2 milliampere. So this is 12, 14, 16 milliampere for this particular frequency over there. So similarly, you should keep changing the frequency and keep taking the reading. Fill first column with different frequency ranges. Then, okay, so in fact, I'm sorry, I didn't take the resistance out. So first I was supposed to take the resistance out. So this is 50 ohm I had taken. So then what you need to do? You need to take 100 dial frequency as 100 hertz, 200 hertz, 300 hertz, etc. and keep putting the readings into the table. Okay, and once you had completed the readings for 50 hertz, next time what we are supposed to do, another value for R is 100 ohm. So 100 ohm is here. Okay, so take 100 ohm, again repeat the whole thing, start from 100 hertz, go up to 1000 hertz, and then the third is 200 hertz. So after we had completed this table, what we need to do is to plot actually these 3 different curves on a graph paper, on the same graph paper basically, I versus frequency. And here is an example of how that curve look like. So here is the curve. So it will come like this. So obviously this is your frequency, and you know at resonance you get the peak. So if you drop a line, that will give you the value of FR. Okay, and the corresponding current would be I max. Now if you draw a horizontal line at I max divided by root 2, which is 0.707 I, that line will cut this curve at 2 places, and if you draw the vertical lines from those places, those would represent F1 and F2. This difference of these two frequencies, F2 and F1, would be the bandwidth of this LCR circuit. Okay, so obviously because you have 3 curves, so you will have 3 different bandwidths and the resonance frequencies, which will hopefully be the same. Now you have this formula through which you could calculate the quality factor. So let me show, where is it? Q value. So omega R, you could calculate omega R, which is 2 pi FR, which is 1 over root LC, where FR is the resonance frequency. And then the quality factor for the circuit, I could not see the formula. It should be somewhere here. So okay, so here it is. Quality factor is resonance frequency upon bandwidth for a given value of R. So it is just the ratio of the FR versus the bandwidth. So you should calculate the bandwidth. You should calculate this quality factor for 3 different values of resistance. So those are all calculations. I hope I had demonstrated this experiment properly. So all you need to do, I will supply you actually the observations on this table that I showed, and after that you need to plot and perform your calculation. That is how you will be able to complete your experiment. Thanks a lot.